Welcome to the Big Bear Math channel. Today we're going to dive right in and focus on multiplying and dividing polynomial expressions as we continue to build on our algebraic foundation. And so jumping right into multiplication here, there's two key ingredients. If we can get these two things down, we're going to have a lot of success today. And that first one is something you're probably already comfortable with, and that's the distributive property. And it could go, I want to give you a couple different variations. We could say A times the quantity B plus C. And as we distribute that A, we're going to get A multiplied by B plus the product of A multiplied by C. Now, the key is it doesn't have to be an addition sign right there. So if we had A times the quantity B minus C, we could still distribute and get the product of A and B minus the product of A and C. Okay, now the second key ingredient, and this is going to be super important today, is what we call our rules of exponents. And if you're going to multiply two terms, they've got to have the same base. That's the key. We're going to add those exponents. So what does that look like? In general terms, we'd say x to the m multiplied by x to the n power is equivalent to x to the m plus n. So in a nutshell, here's the key. They got to have the same base, right? Okay. If this base is the same as this base, you're going to keep that base the same and just add those exponents together. That's all you got to do. But key here in your notebook, emphasize they got to have the same base. So what does that look like as maybe a specific example? Let's say I had x to the fourth multiplied by x to the third. Okay, the product would simply be x to the seventh. So let's see if we can use those two key ingredients, kind of put it all together here and multiply these following expressions. All right, let's see what we got cooking. Number one, I'm going to take this 4x, I'm going to distribute it to the 6x, and then distribute it to the negative 2. So in slow motion, it's going to look like 4x multiplied by 6x minus 4x multiplied by 2. Okay, so to multiply these two terms, I'm going to get 24x to the what? Yeah, it's going to be squared because I had an invisible one here, an invisible one here. Add them together, you get the squared minus 8x. And that's your final answer. We actually can't go any further. We would classify, we'd say that this term and this term are not like terms, so I can't combine them or go any further. So that is my final answer, 24x squared minus 8x. All right, let's take this 2x cubed and distribute it all three times. So in slow motion, this is going to be 2x cubed multiplied by 5x squared minus 2x cubed multiplied by 3x plus 2x cubed multiplied by 4. And let's see. Okay, so to multiply these guys together, 2 times 5 makes 10. That's easy. Now add this exponent to this exponent, and you're going to end up with x to the fifth for your first term. All right, here we're going to get negative 6 for a coefficient. Remember, there's an invisible 1, so add the 3 and the 1 to get x to the fourth. And then that last term is going to be 8x cubed. So there's your final answer. Now let's focus on dividing. How am I going to divide these expressions? I feel pretty good about multiplying them. Now, how am I going to divide them? The key today, because it gets infinitely harder if this part isn't true. The key today is that we're dividing by a monomial. Once you start to divide by a binomial or a trinomial, that's going to be part of a really advanced class that you'll take down the road. So we're going to use what I like to call the distributive property for division. You're like, wait a minute. I know the distributive property. I've only seen it applied to multiplication. Well, there is kind of a counterpart that we use for division. So it would look like this. Here's one example. What if I had A plus B and I wanted to divide it by C? What we're going to do is we're going to divide each term in the numerator by that monomial in the bottom. So it's going to be A divided by C plus the quotient of B divided by C. And of course, if this was A minus B divided by C, we'd get something very similar. We'd get A divided by C first minus B divided by C. And this distributive property for division is an awesome tool that you're going to use throughout your entire math career right up through college, I bet. And then the second key ingredient, again, is we're going to focus on properties of exponents. In this case, when you're dividing two powers, they've got to have the same base. And now we're going to subtract instead of add those exponents, which I think is fairly intuitive. That makes a little bit of sense to me. So for in general sense, if I had x to the m and I wanted to divide it by x to the n, I'm going to keep the base and subtract those exponents. And just talk yourself through it. We're going to keep the base, subtract those exponents. So an example would be like if I had x to the 7th divided by x to the 4th, I'm going to keep the base, subtract the exponents, and end up with x cubed for my final answer. All right, coming down the home stretch here, I think you're going to be pretty impressed with how well you do on these last two problems. So again, what we've got here is I've got a big old trinomial being divided by a monomial, and we are going to go ahead and split that bear up. And so using that distributive property for division, we're going to take the first term, divide it by 2, take the second term, divide it by 2, take your third term, divide it by 2, and then we're just going to simplify each individual fraction that we've created. So 8x squared divided by 2 makes 4x squared minus, and then we get a 3x and a 5, and bingo, we are done with that problem. Now, what was kind of friendly about this problem is that when you looked at this monomial here, it was just a constant, we call it. It was a single number, and it didn't consist of any variables, so it made the division that much easier. In this next example, we are going to see an a squared as a part of that denominator, which is going to give us a chance to not only practice our distributive property, but also those rules of exponents that we talked about. All right, so let's see if we can scroll a little bit here. So we're going to go ahead and split this bear up. And we're going to take the first term, 20a to the 5th, divide it by 5a squared, plus 35a to the 4th, divided by 5a squared, minus 40a cubed, divided by 5a squared. And as I start to reduce, we could say, well, a coefficient of 20 divided by 5 makes 4. So I'm actually dividing, just like it kind of implies. But when you get to those exponents, we're going to subtract to get 3. 5 minus 2 makes 3. Okay, 35 divided by 5 is 7. And then subtract those exponents to get a 2. 40 divided by 5 makes 8. Subtracting those exponents is going to give me a to the first. And there is my final answer. Hey, I hope you found something that was really helpful, maybe cleared something up from class that you saw earlier today, and hopefully you can take that confidence into your next assignment. If you found it helpful, please hit subscribe below and share them with your friends. Have a great night.